Hello everyone, this is Jahnavi Ande. Now, me and my teammates Jubli Sri Jyoti and Jyoti are going to give a PowerPoint presentation on random module and pandas from Python under the guidance of Dr. M. Prasad, PhD, Associate Professor, Department of CSE, Sri Vishnu Engineering College for Women, Bhimavaram. Introduction to random module. The random module is a built-in module to generate the pseudo-random variables. It can be used to perform some actions randomly, such as to get a random number, selecting a random element from a list, shuffle elements randomly, etc. It uses a pseudo-random number generator (PRNG), which is an algorithm that produces a sequence of numbers that appears to be random but is actually deterministic and reproducible when given the same seed value. List of all functions in Python random module are followed further with examples. Seed syntax random.seed of L, version. Parameter L, any seed value used to produce a random number. Version, an integer used to specify how to convert L into an integer. Returns a random value. Get state syntax random.getState returns an object with the current internal state of the random number generator. Set state syntax random.setState used to restore the state of the random number generator back to the specified state. Get rand bits syntax random.getRandBits of n. Parameter n, number of bits required to produce a random number. Return an integer with a specified number of bits. Rand range syntax random.randRange of start, stop, step. Parameter start, number consideration for generation starts from this. It is optional. Its default value is 0. Stop, numbers less than this are generated. This parameter is mandatory. Step point of generator. This is optional. Default value is 1. Returns a random number within the range start to stop. Rand range has few exceptions. It raises value error if stop less than or equals to start, and also when number is not integral. It is explained with examples. Randint syntax random.randint of start, end. Parameter start, end. Both of them must be integer type values. Returns a random integer in range start to end, including the endpoints. Randint also has few exceptions. It raises value error when the parameter passed is not integer, and it raises a runtime error, that is a type error, when the parameter passed is a character other than an integer. Now my friend Jubli is going to take over.
Choice syntax is random.choice of sequence. Parameters are sequence equals to can be a list, tuple or string. Returns a random item. Choices syntax is random.choices of sequence, weight equals to none. It is optional. Weights equals to none, optional. K equals to 1, optional. Parameters are sequence equals to can be a list, tuple or string. Weight the possibility for each value. Third one is weights the possibility for each value, but in this the possibilities is accumulated. K, length of the returned list, returns multiple random elements from the list with replacement. Next is sample. Syntax is random.sample of sequence, k. Parameters are sequence equals to can be a list, tuple or string. K equals to an integer value if specified. The length of a sample returns a particular length list of items chosen from a sequence. Random. Syntax is random.random. returns a random floating numbers between 0 and 1. Uniform. Syntax is random dot uniform of int x comma int y. Parameters are x equals to lower limit of the random number required to generate, y equals to upper limit of random numbers required to generate. Returns the generated floating point random number between lower limit and upper limit. Triangular. Syntax is random dot triangular of low comma high comma mod. Parameters are low equals to the lower limit of the random number, high equals to the upper limit of the random numbers. Mode equals to additional bytes. Low is less than, mod is less than high. Return a random floating point number within a range with a bias towards 1. Next is beta variate. Syntax equals to random dot beta variate of alpha comma beta. Parameters are alpha equals to greater than 0, beta equals to greater than 0. Return a random floating point number between 0 and 1 with beta distribution. Expo variate. Syntax equals to random dot expo variate of lambda. Parameters are lambda equals to a non-zero value. Return a random floating point number with exponential description. If the parameter is positive, the results range from 0 to positive infinity. If the parameter is negative, the results range from 0 to negative infinity. Next is gamma variant. Gamma variate. Syntax equals to random dot gamma variate of alpha comma beta. Parameters equals to alpha is greater than 0, beta is greater than 0. Return a random floating point number with a gamma distribution. Next is Gauss. Syntax is random dot Gauss of mu comma sigma. Parameters are mu equals to mean, sigma equals to standard deviation. Return a random floating point number with a Gaussian distribution. Next is log norm variate. Syntax is random dot log norm variate of mu comma sigma. Parameters are mu equals to mean, sigma equals to standard deviation greater than 0. Return a floating point number with a log normal distribution. Next is von Mises variate. Syntax is random dot von Mises variate of mu comma kappa. Parameters are mu equals to mean angle expressed in radians between 0 and 2 star pi. Kappa equals to concentration parameter greater than or equal to 0. Return a random floating point number with non-Mises distribution or circular normal distribution. Next is normal variate. Syntax is random dot normal variate of mu comma sigma. Parameters are mu equals to mean, sigma equals to standard deviation. Return a random floating point number with a normal distribution. Pareto variate. Syntax is random dot Pareto variate of alpha. Parameters equals to alpha is shape parameter. Return a random floating point number with a Pareto distribution. Variable variate. Syntax equals to random dot variable variate of alpha comma beta. Parameters are alpha equals to scale parameter, beta equals to shape parameter. Return a random floating point number with variable distribution.
Myself Jyoti. Now I am going to explain about introduction of pandas. Pandas is an open source Python library providing high performance and data manipulation and analysis tool using its powerful data structures. The name Pandas is derived from the word panel data, an econometrics from multidimensional data. Pandas library is built on top of the another package named Py, which provides support for multidimensional arrays. What can you do with panda frames using pandas? Pandas makes it simple to do many of the time consuming repetitive tasks associated with working with data, including data cleaning, data fill, data normalization, merges and joins, data visualization, statistical analysis, data inspection, loading and saving data, and much more. Cleaning data. Cleaning data is an important step in data analysis and manipulation using pandas, a popular Python library from data manipulation and analysis. Pandas provides various functions and methods to clean and pre-process data efficiently. Here are some techniques for cleaning data with pandas. Handling missing values. Here are some functions of handling missing values. Identify missing values, count missing values, drop missing values, fill missing values, interpolate missing values. Handling duplicates. Here are some functions of handling duplicates. Identify duplicates, remove duplicates. Handling inconsistent data formats. Here are some functions of handling inconsistent data formats. Phase data, convert numeric values. Handling inconsistent data. Here are some functions of handling inconsistent data. Standardized text, convert data types, rename columns. Handling incorrect or inconsistent values. Use domain knowledge and data validation techniques to identify and correct incorrect or inconsistent values. For example, check for values outside to accept ranges for use reference data for validate values. Handling outliers. Here are some functions of handling outliers. Identify outlier, handle outliers. Thank you.